এই ভিডিওটোত ক্লাছ 12 চেপ্টাৰ নম্বৰ 3 ফিজিক্সৰ ইলেক্ট্ৰিক কাৰেণ্টৰ বিষয়ে পঢ়িম। তোমালোকক ভালদৰে বুজাই দিম। The rate of flow of electric charge through a cross section of a conductor is called electric current. Electric current হল কোনো এটা কন্ডাক্টৰৰ মাজেৰে এটা ইউনিট ক্ৰছ সেকশনাল এৰিয়াৰ মাজেৰে যিমানখিনি ইলেক্ট্ৰন পাছ কৰে পাৰ ইউনিট টাইমত that is called electric current. So if dq amount of charge passed in dt time through a cross section of the conductor, then dq by dt is the amount of current passing through that conductor. If the current is steady, that means if constant current is flowing through that conductor, then I is equal to q by t, that is q is the amount of charge flowing in time t. SI unit of current ampere. 1 ampere is equal to 1 coulomb per second. That means if 1 coulomb charge is flowing through a conductor in 1 second, then that amount of current will be 1 ampere. So in 1 coulomb there is a 6.25 into 10 power 18 electron. So this amount of electron if passes per second, then that is the amount of current is 1 ampere. Charge on a electron proton are the electron or charge given minus 1.6 into 10 power minus 19 coulomb and proton or charge given 1.6 into 10 power minus 19 coulomb. Electric current is a scalar quantity. Eto scalar quantity hoy, so dimension of current is a ampere. Next, drift velocity. We know that electron is flowing as a current through the conductor, then there should be some velocity of that flowing electron. So average velocity of the charge carrier is called drift velocity. It is denoted by b suffix d. So bd is equal to negative for electron and positive for proton. Equation: bd is equal to q e tau by m. This is the expression for drift velocity, where q is the charge of that charge carrier and e is the electric field, tau is the relaxation time. That is the average time required, average time between two consecutive collisions of that flowing electron. Bd is equal to q e tau by m. M is the mass of the carrier, charge carrier, that is proton or electron. Tau is the relaxation time, E is the electric field, and Q is the charge on that charge carrier. So current in terms of drift velocity, so you will get the equation I current is equal to N Q A B D. That is, A is the cross sectional area, Q is the charge on the charge carrier, N is the number density, that is the number of charge carrier per unit volume of that conductor, and B D is the drift velocity. Then if N Q A B D multiply, you will get the current through that conductor. Current in terms of drift velocity, আমি ইয়াৰ ডেৰিভেশ্যনৰ বিষয়ে ধুনীয়াকৈ চাওঁ। তো কাৰেণ্ট ইন টাৰ্মছ অফ ড্ৰিফ্ট ভেলচিটি, আমি যদি কনচিডাৰ কৰোঁ এটা কণ্ডাক্টৰ যাৰ মাজ ক্ৰছ ছেকশ্যনেল এৰিয়া হ'ল এ আৰু এন হ'ল নাম্বাৰ অফ ইলেক্ট্ৰন পাৰ ইউনিট ভলিউম. চ' A is the area of cross section, N is the number of carrier per unit volume, and BD is the drift velocity, and Q is the charge of that charge of carrier, that is the charge carrier. So total charge is equal to N number density into volume of that conductor. So N into volume. So volume পোৱাৰ কাৰণে আমি কি কৰিব লাগিব, ইয়াৰ ক্ৰছ ছেকশ্যনেল এৰিয়াৰ লগত যেহেতু এইটো চিলিণ্ড্ৰিকেল, গতিকে এৰিয়া ক্ৰছ ছেকশ্যনৰ লগত লেন্থ মাল্টিপ্লাই কৰিলে আমি ভলিউম পাম. চ' গতিকে N into N NaL. Al means volume and Q is the charge on that charge carrier. So NaL into Q, total charge, NQAL. This is the total charge on that conductor, and current is equal to total charge flow divided by total time. So this is the amount of charge flowing, and this is the time is t. So NQAL divided by t is the current, and NQAL, so L by T will be the velocity. So NQAL BD is the drift velocity. So you will get I is equal to NQA BD. Since current is a scalar quantity, so it is taken as positive for proton. So we will write NQA BD. So NQABD, since we take the current for flowing proton only, so proton's motion is taken as a current direction. So current I is equal to NQABD. So Q hall yete charge of that proton. Current density, the current per unit cross section area is called current density and it is denoted by J. It is the vector quantity, its direction is same as drift velocity, and J is equal to current divided by cross sectional area. The amount of current passing through a per unit area of cross section is called current density. So J is equal to, if current I put NQABD divided by A will be cancelled, so NQBD will be the current density, and current density is a vector and it is directed to the direction of drift velocity. I and J independent of sign of the charge carrier, so Q is taken as positive, so I is equal to NQABD modulus of IQ and J is equal to N modulus of QBD. These are the equations for current and current density. Mobility, it is defined as the magnitude of drift velocity per unit electric field. It is denoted by mu. That is the drift velocity divided by electric field. You will get mobility mu. And if you put Q E tau by m, that is the drift velocity divided by electric field, you will get E cancel out and Q tau by m all mobility. So it is a scalar quantity, it is positive for both electron and proton. This does not depend on the proton or electron, it is always positive for all the charge carrier. SI unit meter square per volt per second, and dimension will be m inverse L0 T square into A. That is the dimensional formula for mobility. Ohm's law, it states that the current I flowing through a carrier conductor is directly proportional to the potential difference B across the ends of the conductor provided physical condition, that is length, area of cross section, temperature of the conductor are kept constant. V is proportional to I, B is equal to IR, R is equal to B by I, where R is the constant of proportionality called resistance of the conductor. The resistance, it is the obstruction posed by the conductor to the flow of current through it. The SI unit of resistance is ohm and the dimensional formula is ml square T minus 3 A minus 2. Conductance, the reciprocal of the resistance is known as conductance. It is denoted by Z. Z is equal to 1 divided by R. SI unit of conductance is ohm inverse or MHO or Siemens. And its dimensional formula is per M per L square T cube A square. The resistance of the conductor, R is equal to V by I. So B is equal to EL. So EL divided by I is NQABD. So also BD is equal to Q E tau by M. So E cancel, M is goes up, M divided by N Q square tau divided by L divided by A. R is equal to rho, we can also write R is equal to rho L by L divided by A. So rho is equal to M divided by N Q square by tau. That is called the specific resistance of the conductor. It depends on the material of the conductor and it is also denoted by rho. The SI unit of resistivity is ohm meter and dimensional formula is ml cube T minus 3 A minus 2. L is the length of the conductor, Q is the charge of electron and A is the area of cross section, L is the length of the conductor. Q is the charge of the proton or electron. Conductivity, the reciprocal of resistivity is called conductivity or specific conductance. It is denoted by sigma. Sigma is equal to 1 divided by rho. 1 divided by rho is m divided by n q e square tau. M divided by n e square tau. So this will go up, n is square tau by m. Sigma is equal to n is square tau by m, where mu is Vd by E, so E tau by m. So E tau divided by m, we can write mu mobility. So n E mobility, n E mu is equal to sigma. That is the conductivity. The SI unit of conductivity is per ohm per meter or Siemens per meter or MSO mho per meter, and its dimensional formula is per m per L cube T cube A square. If the conductor is in the form of wire of length L and radius R, then its resistance is R is equal to rho L divided by A, that means pi R square. If a conductor of mass M and volume B and density D, then its resistance R is equal to rho L by A. If we multiply L upside and downside, then rho L square by A into L. So rho L square divided by AL means B. So rho L square, that is volume is mass by density. So density will go up. So rho L square D divided by M. The relationship between J, sigma and E. J is equal to sigma E. It is the microscopic form of Ohm's law.